Solve the following exponential equation. Round your answers to 3 decimal places where applicable. So we'll know if it's going to require a decimal approximation if when we get to a point where x is solved for, there's an expression that can't be evaluated down to an integer. You can always leave your answers as exact answers, but I'm going to also show you how to uh, get approximate values so that you can do that if requested on a test. So we have an exponential function which has an exponent that is a variable. And that's a problem because that's a very difficult thing to solve. Now, under certain conditions, like for instance, if I had 2 exponential expressions and the bases of each of those could be written as one another easily, well, then in that situation, I could potentially solve this very easily. That doesn't look like the case here. However, I think there is a way we can solve this one fairly easily. First off, if you just remember the property that anything to the 0 power is equal to 1, then that pretty much tells you that the only value that you could raise 12 to and come up with 1 is 0. So just using that, you could determine that x was 0. But if you didn't, then another approach you could have done is change this into logarithmic form. So logarithmic form would look like a log base 12 of the value 1 is equal to that exponent, which is x. Now, how do we figure out what log base 12 of 1 is? Well, you could use your calculator, as long as you recall that you can't do base 12 logarithms on your calculator directly. You have to change and use the uh, change of base formula. And the way I like to use the change of base formula is to just take the natural logarithm, well, I'll write this out. The natural logarithm of the argument divided by the natural logarithm of the original base. So that's the natural log of 1 divided by the natural log of 12. And that results in 0. So there's another way that you could very easily determine that the solution here should be 0.